How far will my tank cleaner clean? This is a question we get asked a lot at spray nozzle people when sizing up new or upgrading tank cleaning systems. At what distance from the tank cleaning head will it still be effective? Obviously this is clearly a very important question to understand and answer. Now, on tank cleaning data sheets you'll typically see 1 or 2 figures reported with regards to reach or cleaning length. On spray balls and other static cleaners you'll typically see a rinse diameter or radius reported. This is sometimes called the wetting radius. Okay. On spinners you'll typically see 2 figures reported, and this will be a rinse radius like the spray ball, and then also a scrub radius which will be lower than the rinse radius. And then on rotary jet cleaners what we see is an effective cleaning jet length or scrub radius reported, and not typically the wetting radius. So why on some tank cleaners do we report both figures, and why on others do we report only one of those figures? And in order and what do they mean in terms of, when it comes to sizing up tank cleaners? In order to understand that, we just need to have a quick step back and look at how tank cleaners actually perform their cleaning. Now, there's 2 primary functions, 2 primary ways in which tank cleaners actually deliver cleaning. The first is mechanical action. Okay, this is the actual impact of the fluid on the side of the tanks to dislodge any residue that may be there. And the second important effect is effectively chemical action, and this relies on a kind of cascading of the liquid down the walls of the tank to dissolve dissolve residues over time. So two primary mechanisms: mechanical action and chemical action. Now, for completeness, any cleaning action also has a heat element and a time element, but we won't get into those there. So different tank cleaners have a different primacy on one of those 2 actions. So some deliver cleaning primarily through mechanical action, and some through this cascade effect. So for spray balls, almost all of the tank cleaning is performed by this cascading solvent effect of the wash liquid running down the walls. So spray balls have very little impact, very little mechanical action when it comes to cleaning. So the rinse radius of the spray ball represents the horizontal distance at which the spray ball will deliver water well to the wall of a cylindrical tank. If a scrub radius is reported, it will be some distance below that, but it's not common to have scrub radiuses on spray balls. So when judging a spray ball's effectiveness, we need to ensure that the horizontal distance from the tank wall to the spray ball is at least within the rinse radius. Otherwise, liquid is not going to reach the wall in a sufficient way to perform that cascading down effect, which is the primary cleaning action of a spray ball. Now, as long as we get a decent amount of liquid on the wall, it's going to work okay. What we don't need to do is to have every part of the tank within that rinse radius. So particularly the lower parts of the tank, they're not going to be within that rinse radius. But that's okay, because as long as we're getting it onto the walls are further up in the tank and it's flowing down, it's going to perform cleaning well over time. Okay. When we move on to spinners, we'll normally see both the scrub and the rinse radius reported. Now, if we want a light rinse, and say it's a fairly easy residue to get off, then we just need to get a good proportion of the water onto the walls in the same way as a spray ball. So we can use the rinse radius for this in exactly the same way as we would with a spray ball. However, if we want to utilise the spinner's improved mechanical action and drive efficiencies in tank cleaning through that, because increased mechanical action also means increased efficiency, then we want to keep the distance from the spinner to the tank wall within the scrub radius that's reported. Okay, and this is a kind of judgment call as to where a decent amount of mechanical action is delivered, and so the tank cleaning efficiency will be improved. So if we want to get the most out of our spinners, we want to keep them within the scrub radius and not the wetting radius. Now, if we're looking at rotary jet cleaners, we only tend to report the effective jet length or scrub radius of that cleaner. And the reason for that is that these cleaners, their primary mode of action, primary mode of cleaning, is actually mechanical action. The cascade effect is still important, but it's a secondary effect. So this being the case, what we want to actually do is keep all of the tank parts being cleaned within that jet length. So we're not going to just measure from the tank cleaner to the horizontal distance to the wall. What typically we would want to do is measure from the tank cleaner to the furthest point of the tank that needs to be cleaned. Normally that's the kind of bottom corner of the tank, and we want to keep that distance within the effective jet length or scrub radius of the tank cleaner, and that way we're going to get good impact on every single part of the tank. Yes, we'll get the cascade effect as well, but what we want to get is good impact on all parts of the tank to have a really effective cleaning and get the most out of these tank cleaners. Now, with very large tanks or very tall tanks, it may not be possible to get the bottom corner within that jet length, and that's okay as long as the residue isn't too tough. You probably get away with that because we are still getting all of that cascade effect down the wall as well. But if you want to get the most out of them, try and keep every part of the tank within that jet length if possible. Now, for high pressure cleaners, it's got to be noted that so this is tank cleaners that are running at sort of 50 to 100 bar even, or even more. It's got to be noted that those effective jet lengths actually come down quite a lot. For mid-range rotary jet cleaners, the effective jet length goes up with pressure. So running it at 3 bar, it will maybe have a jet length of 5 meters, and running it at 10 bar, it may be 12 meters or so. But when it comes to very high pressure cleaners, rotary cleaners, the actual jet length actually comes down. This is somewhat counterintuitive, and the reason for that is because they're running at such high pressures, and because typically they're running at very, very low flow rates, which is the whole point of these tank cleaners. We've got very kind of fast moving needle-like jets, and after a few meters they start to break up and atomize because they're moving so fast. So it needs to be noted that those high pressure rotary jet cleaners that run at sort of 50, 100, 150 bar, they're not suitable for those very, very big tanks with long clean distances, because their effective jet lengths actually come down despite the higher pressure. So that's worth noting. So I hope that guide was useful. I hope that answers the question, and if you've got any other questions on any aspects of tank cleaning, please give us a call. We're here to help. We've seen pretty much every kind of tank cleaning situation you can imagine, and can hopefully offer you some good advice.